pick this group and just come up to the board and kind of work it out. We'll talk about it now. Set of 3 lines should be. So pick one of each 3 different types. I have three different groups. So okay. But the last one, the idea of the last one is the goal for these radicals is there are 2 things. One, you don't want any factors inside that are bigger than the index. Like here, up with an exponent bigger than the index. Here we have an x to the 9. That 9 is bigger than 3. So we can simplify that. 9 times 1/3 is 3, so that comes out as an x cubed. The y to the 11th was bigger. 11 was bigger than 3. So we took a bunch of groups of 3 out. The 11 we took 9 off, left 2 of them. And then y to the 9th to the 1/3 is just y cubed. Then the y squared to the 1/3. Well, you can't do much with that. It stays inside the radical. And the 54, we saw that was 2 times 27. The 27 to the 1/3 was the cube root of 27, which was just 3. And the 2 to the 1/3 just stays inside the radical. So that's as much as you can do with that one. The non-thinking response to this problem is to simplify that as what? 3 plus x. That's kind of a, it seems like it should work. My dog knows that it doesn't. I'll tell you why. If I'm walking down the street and here's x and here's 3, I'm walking down the sidewalk like this. What's the hypotenuse distance? What is the hypotenuse? C is the hypotenuse here. What does it say about the Pythagorean theorem here? C squared is equal to what? A squared plus b squared, which in this case would be x squared plus 3 plus 9, right? That's Pythagorean theorem. Which means the hypotenuse actually here is equal to the square root of x squared plus 9. And my dog knows that he sees a rabbit over here. The dog, he knows the Pythagorean theorem. He says, I'm not going to run down there to the corner and go on the sidewalk. He's going to tear right across the grass and go here because this distance here is much smaller than going, this is 3 plus x here. It's much smaller than going on the sidewalk, going x units and then 3 units. So Pythagorean theorem is pretty inherent. But if we think about it, we would not make this mistake. The reason we make that mistake, I think, is because we're so used to seeing multiplication here. And the square root of the product is the square root of the first times the square root of the second. But it doesn't work for addition or subtraction. The same thing is true if you have x plus 2 squared. You just take the square. It isn't just x squared plus 2 squared. There you have to go through the pain in the butt. You have to multiply it out. This is the way I would always write it down. Rather than memorize the formula for that, I just, multiply it out. You have 3 minus 2 root x times 3 plus 2 root x.
Do they cancel?
So we get 6 root x here, and then we get minus 6 root x. Yeah, they drop out. That's beautiful. So with the last piece, though, what happens there? You get this thing times this thing. It'll be 2 times 2 will be 4, and root x times root x will be that. Should just be an x. See, that square root should be gone there. So it should just be minus 4x. The whole hope here, what made us do this was that we get rid of that radical. And this only works with square root radicals when you have binomials. You can do it with cube root radicals, but it's a little more complicated. You need a bigger expression here. Kind of like something that you had when you took the difference of 2 cubes. You need 3 pieces here So good to know usually it doesn't come up often enough to reserve a spot in the algebra books, I guess. Not the little algebra books, the bigger algebra books. Oh, by the way, I was looking at a website yesterday, the New York Times, I read the New York Times online, and there was a cool recommended email for me. I don't know why, but I must look at geeky stuff once in a while. But it's called the Pi Machine. Here's the deal. If you have a wall here, and two marbles, the same size marbles, and you have one marble sitting there, and you roll this marble down, and it runs into this. You have a wall here, and you have a marble here and a marble here. You roll this marble down, just roll it down the table. It hits this marble, and you hear a click. Then the first marble sits still, just like you're playing pool. If you're in a pool, it would be like if you had a pool. If you're on a pool table, you have two pool balls. You take the first ball, you hit it towards the second one. The first ball sits still. The second ball goes down to the cushion and bounces back. And it comes back, and let's say it comes back in a straight line and hits this ball. So as it comes, it hits the wall. That's our second click. Then it comes back here, hits this ball. The third click, and this ball just rolls away. And let's just say it kind of rolls off the table now. So there's 3 clicks, and that's the first digit of pi. It's 3. But what happened? That's okay, big deal. It just happened to be 3. But if you take 2 other balls, instead of thinking of it as maybe a car and a bicycle, if you make this one car here 100 times bigger than the bicycle, and you've got a concrete wall here, and the bicycle is kind of a rubbery bicycle, it's elastic. The car's coming down maybe at whatever speed, it doesn't matter. Hits the bicycle's sitting still. The car's 100 times heavier than the bike. Hits the bike bounces ahead, hits the wall, bounces back, hits the car, slows the car down a little bit more. It bounces back towards the wall, it keeps bouncing back between the car and the wall. Hits the car and the wall a whole bunch of times. Eventually it hits the car enough that the car starts rolling back. It just keeps hitting, and the car starts rolling back at almost the same speed it came at. The amazing thing is if the car is 100 times more than the bike, the amazing thing is that the number of collisions that will happen is exactly 31. If you take 31 over 10, you get the first 2 digits of pi. I couldn't believe this. And I sent out an email to the math department saying, this is pretty cool. I don't know if it's true. But it should give you a few hours, maybe days, hopefully not years of pleasure trying to figure it out. But I think I got it more or less figured out. So if you take something that's 100 times 100, 10,000 times bigger in mass, and you take like a little mosquito in a car, and you do the same deal, you'll get 314 collisions before it will stop, before the car will eventually go back away. So it's called a Pi Machine. I mentioned this because Friday is Pi Day. Pi Day is March 14, 314. Big day. Okay. Let's look at, the material for today was on division. So let's look at, just go through the note summary for that. So division it's thought as undoing multiplication. Addition was combining things together to get a big group. Subtraction was kind of taking the big group and taking a bit off and get one of the pieces that you started with.